Okay, the next thing we're going to do, we're over here at the Bridgeport, and we're going to take this part, and we've got a 3/8 slot that goes through the part. So part of our setup is we need to hold it very firmly, and a collet block is probably ideal for that. So we stick it in a collet block. With these collet blocks, you need to observe that there is a groove in the back of the block that aligns to a screw back there. We can put on the nut. Be careful not to cross thread it. And collet blocks are one place you don't want to be timid about tightening them. So what I'm going to do is I'm actually going to put this collet block backwards in the vise so that I can take this special wrench, and notice this wrench is quite a bit beefier than anything that ever comes with the collet blocks. And I'm going to tighten it, of course, but then here's the part that's going to make you cringe. I tighten it and then I take a hammer. I guess that's not too bad, but I really do not want this thing loosening up. If it loosens up, not only did I lose my part, but I've lost a very expensive cutter. So now that that is tight, I'm going to flip the block around, put it right back in there. I want just the nose of the part hanging out. Tighten her up. And move this out of the way. We're going to put our cutter in here. Okay, so we have this cutter here. We need to calculate what the speed of the cutter is going to be. So I measure the cutter, and it's actually a 3-inch diameter cutter. So I got my calculator here. And I do 4 times 70, which is our surface feet, equals 280 divided by 3 inches. I come up with about 93 RPM. It's very slow for this cutter. Or it's what it's supposed to be for this cutter. I guess it's just very slow compared to what we're used to. So let's go ahead and put her in low range, and I believe it is. And I'm going to wind her down. I got her out of it just over 90 RPM. And it will be that slow when you cut. Okay, so we're set up there. The next thing we have to do is we have to figure out how we're going to control our depth, to get our depth from the top down so that this cut goes right through the center. So the way we do that is I take a micrometer first and I measure exactly what this diameter is. And it is 8/19. Okay? So I'm going to go over and grab my calculator again. .819 plus the thickness of the cutter, and it's a stagger tooth cutter, so it's a little difficult to measure, but it actually cuts a 3/8 diameter or thick slot. So that's a 0.375 equals 1.194. That's the diameter of this plus the thickness of this. Now if we divide that by 2, 0.597, if I bring this cutter down to it just barely touches the top of that diameter, and then I lower it 0.597, it will put me right in the center up and down of that boss. So let me go over that one more time. The diameter plus the thickness of the cutter. When the cutter touches here, that diameter plus the thickness divided by 2 gives me a depth that I lower that cutter to get right in the middle. Now, to find out when I touch that, I'm going to take my Dykem again and I'm going to ink it up. And I'm going to now bring the part up until I just scratch the top of that part. And I want to really sneak up on it. I don't want this to catch me off guard and then go a little too deep. Any scratch that I put in it right there is going to show. So I'm just sneaking until I see just the slightest scratch on that blue. Very careful. Right there. And then I'm going to back off. And I just barely touch that. I'm going to zero out my knee lever or handle because I'm going to have to count now. And if you remember, we calculated that the diameter plus the thickness of that cutter divided by 2 was 597 thousandths. So I'm going to now raise my table. 1, 2, 3, 4, 597. And that should put me right in the middle. Now the next thing I'm going to do is I'm going to now bring up this cutter to the very end of the part and carefully see if I can find when it first scratches that end. And I'm having the float, if you notice, I'll do it exaggerated, I'm using the Y-axis to kind of drive the part back and forth around that cutter until I can find that little spot right where it touches. Right there. Just a little rumble. Now I'm going to come off of it a decent ways. I'm going to turn off my mill. Make sure my digital readout is on. Waiting for it to come up. Okay, so we have our depth set now, and we touched off on the end of that part. So let's move the cutter off the part. We're going to move in 700 thousandths, which is the depth on our blueprint. And then we're going to cut it. We're going to take the entire thing in one pass, and it's actually better on the cutter to do that. More teeth engaged in the material. So I'm going to turn her on low. Make sure it's going the correct way, and it's critical that this is conventional cutting, not climb cutting. This cutter will destroy in a heartbeat if you try to climb with this. I'm going to lock down my X-axis. My knee is locked down, everything looks good. Now we're going to make one pass through the part. speed. Just like that, 20 minutes of setup, 1 minute cutting.